Good night, everyone, and welcome back to your channel FE Civil Exam with Farhad. Geotechnical Engineering, Part A, Soil Mechanics, Chapter 11, Compressibility of Soil and Consolidation. We want to solve a problem for FE Civil Exam in terms of a consolidation. So we have like a foundation of a building, on top of a three-layered soil consisting of a silt, sand, and clay. So the first layer is 6 feet in height, the second one, the sand one, 5, and the clay one is 8 feet in terms of its height. And also the water table stands at the very beginning of the second layer, which is the sand layer. So the first layer is completely dry, so we use gamma D or gamma dry, which is 110 pound per feet cube for the silt, and then the others are like, you can consider them like gamma saturated because they are like in water. And if we know the liquid limit is 40%, PC consolidation pressure is 1300 pound per square feet for the clay layer, and delta P, the effective uh, increased effective stress due to the loading on the columnar foundation of this building, which applies to the soil, is 500 pound per square feet. The void ratio for the soil or clay layer is 0.9. And also we want to calculate the consolidation settlement at the center of our clay layer. So to start such problem, we need to consider, first of all, we have to calculate from the very beginning of our end of our foundation to the center of desired layer, which is clay layer. We have to calculate the effective stress. So if we call this point like point A, at the center of the clay layer, we need to calculate the effective stress. So sigma prime A from the top is 6 feet of silt in a dry soil. That's 6 times 110. Then comes to the second layer, which is sand, and that's the saturated one. Effective stress is 5 feet times 120 minus gamma W. So this is gamma W in terms of pound per feet cube. And then plus 4 meters at the center of clay times 130, which is gamma saturated minus gamma water, to get the effective stress at the center of clay layer. If you do the mass, it just gives you sigma prime A is 1218.4 pound per feet square. We have the effective stress at the center of clay layer, and then let's see if we have our consolidation pressure is 13 pound square feet at the clay layer, and delta P, and then consider this sigma prime is also like we call it in our formula P naught. So these are all effective stresses. Mhm. And then let's jump to the reference of NCEE's handbook in terms of the consolidation. So we have like these three formula which we go through them for our problem. So they are like possibility A, possibility B, or possibility C to use each of these formula. Mhm. So let's jump to the concept of the formula for consolidation. So we have like case one, which both initial effective stress and then initial plus extra stress, both of them are smaller than or before than consolidation pressure P sub C. We call that case like over consolidated soil. So if P naught plus delta P is less than PC, we call that case like case one, or our soil is in over consolidation, considering the first part. And then the formula for consolidation settlement, it just comes by replacing this coefficient here. H naught is the height of the total height of the layer plus 1 plus E naught times the normal log of P naught plus delta P over P naught. Then the other scenario is exactly opposite of this one. Both feet are standing uh, after P naught, so definitely we are in normal consolidation range. So case one is in over consolidation domain. Case 2 is in normal consolidation domain, and the only difference is we just use CC, coefficient of consolidation, and then CS, we call that swell index or recompression. We are also show that by CR, just in case if you see that in the exam. And the last condition is when one foot one foot stand in before PC and the other one P naught plus delta P, it just goes beyond the P naught. So in such case, we have to dissect our formula and use this bigger formula, which we goes through each of them by detail. So this is the overview of the concept of using this formula, which we reviewed them in the handbook. And now let's go for the first case, or over consolidated soil, which both feet you can consider that as a standing man, which both feet stands before PC, and PC is consolidation pressure, and that stands for the maximum pressure that the soil has experienced during its whole lifespan. So as you can see, both feet of this man, which is P naught and P naught plus delta P, are before PC. So that's definitely case one and over consolidation domain. So in this domain, we just use the settlement consolidation formula, replacing the coefficient for over consolidation, CS recompression, or again, this is also equivalent to CR. We call both of them, so it's like both swell index and recompression index. And then definitely normal log of P naught plus delta P. So both feet are before PC, so PC is not involved in the limit of our log normal log of P naught plus delta P. So it just goes with these limits. And the other case, as you can see, CS is just replaced in the equation for settlement consolidation for case 1. In case 2, you can assume a standing man. Both fits are after or beyond the maximum pressure of the soil. So that's why we call it normal consolidation. And definitely P naught is higher than PC, then definitely P naught plus delta P is also higher than that. This is normal consolidation scenario, the same formula, but the only difference is just we use CC or compression index in the formula. Last time we used the coefficient for the over consolidation. Case 2 is normal consolidation, and then the final stage is like a case number 3. That's like we call that also over consolidation because it's a start in the over consolidation domain, but the difference of this scenario with case 1 is that the first foot stands before the PC, then the other foot just goes beyond the PC. So we have to dissect our problem, like for calculation of settlement, consolidation settlement, we have to dissect the formula to fit it into both domains. So for the first part, for the over consolidation domain, definitely we use C sub S, which stands for soil index times the h naught, the height of the layer we are working for, getting, for example, in our case, that's 8 feet, like a clay soil. Mhm. The thickness of the entire layer over 1 plus E naught times the normal log of, then we dissect our problem. The higher limit is PC and the lower limit is the very beginning of our footstep, and that's for the first part. And then for the second part we add it with the second part is just this coefficient replaced in the for the same formula with this different coefficient and different like limitation for normal log, and the higher limitation is the second foot, but the lower limitation this time because it start like from PC. We dissect our formula, so the lower limit is P sub C. That's all you need to know about the story of this interesting formula for consolidation. Now you can, all the scenarios for our case, we can go back to this is the story of those three formula in the NCAA's handouts. So as soon as we uh, know our case. So for example, our case sigma prime we calculate at the beginning to be 1218.4 pound per feet square. PC is 1300, delta P is 500. Sigma prime is P naught in our formula, and that then our category is like this. PC is 1300 is higher than P naught, but P naught plus delta P is a 1718.4. So definitely our category is the third formula in the NCAA's handout. So this is our case. So we have to stick. We already know the story of this equation. Mhm. Now let's jump to the solution. So our case again is third solution. So that's a over consolidation, consolidated soil, which dissects the formula into two parts. So as soon as we have this one, we can use the third scenario for our case. So SC is the first feed start at the over consolidation ratio, and the higher limit is P naught PC and lower limit is P naught, then added to the normal consolidation part, which the upper limit of normal log is P naught plus delta P over lower limit is PC. And also we do know from the handout that C sub C is equal to this equation, is equal to 0.009 times liquid limit minus 10. So liquid limit is provided, so we can easily calculate our CC, which is replaced by the provided liquid limit, which is here, and we can easily get C sub C, or coefficient compression index is equal to 0.27. Likewise, in the handout at the same page, which you can find this equation, CR or CS is equal to 1/6 of CC. So CR or CS is 1/6 of CC. So if you calculate that, that's 0.045 in terms of our coefficient. As soon as we have both coefficients, so we can easily replace them in our equation. So this is our C sub S, this is our C sub C, this is the H naught, the height of the clay layer. And as soon as we replace the numeric value for both of them and add them up together, you will need to just do the math correctly and add these two numbers. So we spend a lot of time for the story of the behind those formula, but you don't need to go through them, but just know it for once and then use it correctly to speed up to solving your multiple choice questions. So consolidation settlement is equal to 1.72 in terms of inches. So in our problem, it just goes with choice D. One may ask, so what is this not this formula here? Did we even touch this formula or why it's here? So that's like a coefficient of uh, CV. It's a coefficient of uh, consolidation, and that's when you are using the time uh, factor of time, that's CV times T over HDR squared. And that's when you use this equation. But we don't have any of the other concepts relating the time and those things. So this is extra equation which is not useful in our case. Many times in the multiple choice questions, they are just you throw you some random equation related to that chapter to see, for example, if somebody just mistakenly this coefficient like CC or CS. CC or CS. That's why you have to be very careful with the equation. Thank you. We'll solve more problems in soil consolidation. Thank you.